How's everybody doing today? Good. Does anybody need a power nap? Now's the time. Yeah. All right. So my name is Jose Chavez with CA Technologies, Principal Software Engineer. Basically, going to be talking about our journey with OpenShift. Okay. So I'm going to read this verbatim, which will give you a good idea of one of the main motivators for CA Technologies to migrate over to containers. The deployable thing is no longer an executable or a jar file, but a container. That container has everything it needs to run and provides a nice separation between application, code, and infrastructure. Everything inside the container is the developer's responsibility, and all the infrastructure that the container runs on and uses the responsibility of the operations engineer. Key thing there is basically we want to enable the developer to focus on what they do best, right? And not have to worry about having a running environment or a working environment, functional environment. So, and the operations engineers have a better idea of where, you know, kind of the boundaries of their debugging for the infrastructure. So, pretty simple. There's some considerations there. One of them I've heard earlier today around chargeback. So, if I'd love to talk to anybody that has had some experiences around that, be a good conversation for us. So. All right, so everybody meet Billy. Billy represents our infrastructure teams. So the history of CA with SaaS application, or the transition to SaaS, I should say, basically there was no standardized deployment model. This is going back a few years when we first started taking a look at you know, moving SaaS or you know, reinventing the SaaS deployment model. So no standardized deployment model. We were manually deploying infrastructure. You see the common thing here, manually installing common services and manually deploying applications. So it's very manually intensive. Probably pretty boring, you know, to do the same task over and over again, but you'll see growing pains. It's very highly error prone, time consuming, long deployment cycles, and of course the infrastructure team working around the clock to, you know, ensure that either new deployments are met or that deployments are actually functioning. So Billy here is essentially showing picking up, you know, the rocks and putting them on the wagon in no particular order. And I'm not sure if he's actually having fun here or not. I would imagine that instead of putting him into the wagon, he'd probably rather be throwing him, right? So, you know, you can see it's very manual and not a lot of, you know, order here. So, CA's landscape today involves a variety of different applications. You can see the traditional monolithic service N-tier microservices with multiple development processes and running on different infrastructures. So when we were, you know, migrating into this new SaaS model, we wanted to ensure that we didn't leave anybody out. We wanted to accommodate all of, you know, the business units in the organization, the development teams that you know, already existed or, you know, were new to the game, you know, coming up with the latest and greatest you know, type of software. So we had to keep these things in mind, and this is actually where OpenShift comes in and helps, right? So it enabled us to have a single path to deploy, single way to manage you know, these products within the same environment. So why OpenShift? Again, standard application deployment model, right? Predictable for the most part, unless you don't trust your playbooks, right? Hosting on different infrastructure providers, being able to manage your applications, if you're in operations, some form of administrator, being able to manage the services you have out there deployed today through a UI, where, if you wanted to scale an application on demand, or you wanted to set, resource limits on your services. You can do that. A variety of other things, obviously, but those are some of the common ones. The big one for us is implementing a fully automated CD deployment. So, and I'll actually go into that in a future slide here in a minute. And another key part is providing a common shared development environment for developers to use. So, one of the benefits to containerizing and using OpenShift is to reduce the time to market, right? So how do we do that? Some developers like to install, tools on their own development environment or their own, laptops, do building and testing and all that. But what we wanted to do is provide an environment where they didn't have to worry about learning how to install OpenShift necessarily if they didn't want to, and just give them a method by which they could, write their applications and from their own desktop or laptop push, into our shared dev OpenShift environment. So where we are today, we have automated deployment of environments consisting of standardized application delivery, centralized logging, system and container monitoring, Docker image security scanning is a big one for us, and of course CD. Our automation enables us to, it's flexible enough to deploy OpenShift Enterprise and Origin, CentOS, RHEL, like I mentioned earlier, multiple infrastructure as a service providers, and also vary the type of environment that we deploy, HA, non-HA, the size of the cluster, all those things are configurable. And the key point here is the amount of time it actually takes to deploy our environment end-to-end. So on average, between 1 and 2 hours. And just a little history, we actually go back to OpenShift 2, where we were doing this automation, and we had some pains with using that version, but our deployment times back then were probably in the order of like 5 to 6 hours. So it's drastically improved now. In the product overall, OpenShift 3, I think, is far better than it was before, even in addition to incorporating Kubernetes and Docker. I just find it much easier to administer and maintain than the previous generation. Some of the tools that we use to automate our deployments, CA release automation, Ansible, of course, AWS CloudFormation templates, Python scripts, Bash scripts, and Jenkins, of course, for our continuous delivery model. All right, so show of hands. How many today have either an almost complete or fully complete, like automated end-to-end deployment? Okay, so one, maybe 1.5, okay. How many would say, a pretty good amount, but there's there's still some work to do? Okay, good. Anybody that's a Billy in here that's still doing everything manually? Okay, all right, so we kind of fall into the middle there, and I've debated whether, we should be in that upper echelon, right, of having a fully end-to-end deployment, just because I'd probably be working myself out of a job. So, all right, so here's what our technology stack looks like today. Starting from the bottom, you have your infrastructure as a service layer, obviously, VMware being down there as well. Then you have your PaaS layer. Right above that, of course, hosted services on top of OpenShift. we actually have common services that are running inside OpenShift, and we have common services that are outside OpenShift. So the common services inside are analytics, telemetry. Then, of course, we have the hosted applications that are, customer-facing, right, that customers are consuming. On the left-hand side, we have our monitoring solution. It's actually a combination of CA products, APM, ASM, UIM, and then Sysdig down at the bottom for container level performance metrics and reporting or alerting. On the right-hand side, you'll see some of the common services that are running outside as standalone, our DB layer. ELK, we actually use Elasticsearch Logstash Kibana, not the EFK. We go back, we have a history with actually running them as standalone services, so we have that infrastructure in place. We do deploy a daemon set inside all of these, a FileBeat daemon set inside of the hosted services that report back their logging into our centralized Elasticsearch. And then we have Kafka. On the security side, an Expose for penetration testing, physical hosts or any type of host, and then Twistlock for scanning our container images. So we have the Jenkins hipster here, who basically represents our continuous delivery model. So we have two flows, a standard flow and a normal change flow. So the standard flow would actually cover like a small change that is very low risk of breaking things. Doesn't require documentation change, no new feature, and basically there's no human intervention. That flow will actually, that type of change doesn't have to go through the typical change cycle. So it's basically a push by the developers, and it'll go through all the way into the endpoint environment. And then we have our normal change, which is a traditional check-in that requires change management approval. It's a high-risk, training's needed, documentation, and all that. It's a push-button deployment. So inside our in-house Jenkins, the change will actually propagate and then stop inside the Jenkins, waiting for an approved person to go ahead and make the final push into production or the endpoint environment. Failure in either case will utilize OpenShift's failback or rollback mechanism. So here's a high-level overview of both approaches of our CD flow. So on the left-hand side, you have one of many actual CI models. So developer checks in code, a code build is executed, something like Team City can pick that up and actually create a Docker image with those new artifacts that have been built. Depending on how it's tagged, whether it's a normal change or a standard change, it may or may not go all the way. But let's say it's a standard change that does go all the way. There would be two different paths. One, Team City could actually make an API call to Jenkins to notify that there is a new image or a modified image or a change to an image, basically. So what he'll do is Jenkins will pick up that job. He'll scan it with Twistlock and ensure there's no vulnerabilities, no CVEs. And if it's clean, if it fails, it generates a report, and we'll go and notify the appropriate development team to patch those up. It'll come back if it passes, and then it'll actually push into the SaaS-specific location in the Artifactory that we use. and then it'll make an API call. This is all part of the same pipeline. It'll make an API call to Artifactory to actually synchronize that image to bin tray, to essentially mirror that image out in the cloud. And it's key because OpenShift cannot communicate with Artifactory. We can't, transmit that image and due to, obviously security and firewall rule considerations. So it'll put the image in bin tray, and then basically Jenkins will, and it's a synchronous call, so it sits there and waits. He'll trigger a remote job to our CA deployer running in the target OpenShift environment. Now what'll happen is it'll make an API call. The deployer will make an API call to OpenShift to force pulling down the image from bin tray, tagging it locally in the integrated Docker registry, and then pushing it into the integrated Docker registry, at which point an image change trigger occurs, and of course the new images or the changes are now propagated and running in production. So that's one. The other path is Jenkins is actually scanning on an interval against pre-configured locations in Artifactory, and if it detects a change to the image, it'll essentially run through the same path as before. So. All right, so I'm going to do a quick little demo. And it's a simple hello world type application. It's based on AngularJS on the front end, using Jersey on the back end. And I'll field some questions while that's deploying, because it's going to take a few minutes here. So.
So does anyone have a question? Should we take a question now or two? Jose, what?
Yes,
You wanna
actually, let me
get started here?
Let me just show one thing here, and then I will fill. All right, so here's one of our development OpenShift environments that I mentioned earlier, and this is our sample app that I was referring to. We've exposed it out. It's publicly available, Route 53. So if we click on it, it's going to open up, just text-based, simple CA SaaS OpenShift demo. This is actually kind of a guessing game in here, but for all intents and purposes, I just wanted to show actual changes that occur. So this is what it looks like, CA SaaS OpenShift demo portal, and then I'm going to make a quick change. Here. And now I'll field some questions.
Does anyone have any questions at this point? Can anyone read that font? Because I can't. I mean, I'm getting there.
How's that?
There you
Is
go.
that better?
It's a little better. So I absolutely adore live demos. So.
Actually, being that it's now wrapping terribly, let me go back down and make sure I find, here we go, right up there. Oh, I'm not sure what it's doing here, but. Okay, so I'm just going to change this text here to say, what's wrong with the font there? There we go. Let's just put comments, OpenShift, and we'll pull up.
You could write anything there because the font's so small.
Yeah. Okay, so I've just made a quick update, and I'm going to run the actual build. So Maven's going to build this, and then we use Docker Compose. This is just for demo purposes, Docker Compose will actually build the image and then push it out to our Artifactory location.
So they're going to make you grab your microphone again.
Yes.
Do one-handed typing.
I forgot about that. Thank you.
That's okay.
And so once all is said and done, it'll go through the pipeline that I described, and we'll start seeing some changes here on the screen when it actually propagates all the way to the development environment. So, any questions while we wait? It's going to be like 2 or 3 minutes before that finishes.
I was just wondering what was in the CA deployer. Oh,
Yeah, so he's essentially a, it's just like an API layer that's handling the request from Jenkins. So he essentially brokers the request to make the deployment from our on-prem image, to load it into the actual running environment out in the cloud, right in AWS. So he's the, he'll be the one pulling from Bintray out in the cloud, pull it into the local environment, and actually call the OpenShift API to take it all the way into a running container. So, yeah.
Are you doing any kind of image signing when you push it from one internal repository to your external repository, so that when it runs, you're assured it's actually your image that's running?
Very good question. I figured that would come up. Not yet, but it's something that we're looking at, certainly for security reasons. One of the things that we do is provide golden images for RBUs, right? So we're part of the SaaS organization, so we support all of the development teams at our company. So we provide a standard set of Docker images that we're essentially stamping, right, putting a stamp of approval on. So we use, the twist lock to ensure that they're, the vulnerabilities or risks are addressed before we provide them in Artifactory for others to use. So the images that you see that are being scanned when they make changes and push, they're from, tag in the Docker file actually points to our golden images. So that's one aspect, but that, yes, actually signing would be the second aspect there that we want to take a look at. Anybody else?
All right.
So this should be finishing up here in just 1 second. Oh, it looks like it just deployed, yep.
Yeah, deployed.
So let me close this out. Open it up, refresh, and there you
There
go.
we go. Live demos.
It works.